Hello, everybody. Thank you for joining us this afternoon. My name is Danica. I am with 3C Rand County of San Luis Obispo, and today we have our course, the 2025 California Energy Code and Passive House, with our expert Ken Levinson with Passive House Network. And before I pass things off to Ken, I just have a few logistical slides to go over. Next slide, please, Ken. So just a few quick Zoom reminders before we get started. Please make sure you are on mute throughout the duration of the training, and we highly encourage questions. And if any of them do come up, feel free to raise your hand and we can unmute you. And this session is being recorded, which will be shared with you along with the slides in the next few days. And I will also share that in the chat for those who are just joining in. And next slide, please. And for those who are new to 3C Ren, this is just a little bit about who we are. We are the Tri-County Regional Energy Network, and we're a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties. We are funded by ratepayer dollars collected through the public goods charge found in our utility bills, and the benefit of being ratepayer funded and is that there's no cost to those we serve, and we're able to bring those dollars back into our region.
What is going on here? Sorry about that.
No worries. So 3C Rent currently offers 6 programs focused around 3 services. We have incentives, we have trainings, we have technical assistance. And this training today is part of the Energy Code Connect program. And you can find additional trainings and resources and learn more about 3C Rent on our website at 3c-ren.org. And with that, I will pass things off to Ken to get us started.
Great. And hopefully I'll get control of this thing. Sorry about that. I think we've got it now. Welcome. It's really good to be with you here today to talk about the new energy code and passive house and kind of the interrelationship between the two. I first want to introduce the organization that I represent. I'm the executive director of the Passive House Network. We are a 501c3 nonprofit. We are a nationally oriented organization. We have chapters across the country. Passive House California is a very active part of our network and the Passive House network generally in the US. We have members. We really focus on training and capacity building, principally through the Certified Passive House Designer and Consultant course. And we work with another organization, EMU Passive, that provides the Certified Tradesperson course, also in California, which is a great hands-on training as well. We are affiliated with the Passive House Institute, and really a great part of Passive House is that it's a global effort and people working together around the world in different climates, but also similar climates around the world and uses and so on. So it's really exciting and encourage you to get involved. You do not need to be a member to come to chapter meetings or to participate. So I am the executive director, and I know we have AIA and PHI credits available through for this presentation. Just a few notes about myself. I am an architect by background. I practiced for more than a couple of decades in New York. I'm based in Brooklyn, New York. Through my work in architecture, I came across Passive House in about 2009 and was very excited about the possibilities with it, that it was something that spoke to kind of the severity of the climate emergency, as well as delivering a whole host of benefits to occupants, to clients. And I was very fortunate to have an early client sort of take on the challenge. And it was this townhouse, not a new building. This is a pre-Civil War townhouse, over 160 years now old. And we did a gut renovation. but the old structure very much intact, and bring it up to be ready for the next 100 years of operation. And we'll talk a little bit about this probably going through as we go through here today. But for example, all the other townhouses, this is a 5-story townhouse. It's hard to see that exactly. And let me see if I can get my laser pointer on. We've got a ground, 1, 2, 3, 4. There's another attic above, and an occupied attic. The diff the various houses have 12 to 15 tons of air conditioning installed with them. We installed 3 tons. So that's kind of the magnitude that we're talking about in terms of performance difference while maintaining comfort, good indoor air quality, and the rest of it. So today, we're going to talk about both Title 24 Part 6 and Passive House, specifically around the code updates with the energy code in California. It's not going to be exhaustive. There are other presentations out there that get into a much more detail, I know, but we are going to cover a fair amount, certainly, and hopefully enough that we can talk about both things and the relationship of both things. We're going to start with a bit of the goals as I see them uh, and as they are purported to be as well from California and Title 24 and Passive House and the Institute. We'll, after going through the code updates, talk about Passive House more in an introductory way, and then try to have a little bit of conversation between the two. And in the process, dive a bit more detail into Passive House along the way. And we'll finish up by looking at a pretty straightforward case study in Pebble Beach, uh, Pebble Beach, California, in climate zone 3 there. And we're focusing mainly on single family residential, but all kinds of building types will come up. So if you have questions along the way, please feel free to put them in the chat. I will try to keep an eye out for them. I know Danica will try to make sure I'm seeing them, or raise your hand. Happy to go back and forth in conversation if we don't hold things up too much. And then hopefully we'll have time for questions. Well, we certainly, my goal is to have questions for that. So goals of Title 24 and Passive House. And maybe I'm taking a little bit of liberties here, but I think I'm trying to be generally a good guide here. And one of the things we see in energy codes, whether it be California or New York or anywhere in between, they tend to be relative targets. We're trying to improve things, and they tend to be incremental improvements. Passive House has taken a look at the physics of buildings and the physics of performance and said, well, we actually should hit these specific targets. And so it's not about a relative improvement. It's about getting to where we think we should be. Thermal comfort. Now, saying it's not addressed in the energy code is perhaps a bit of an overstatement. It is. I mean, we need people to be comfortable. We need to be able to maintain certain temperatures. And we're going to rely on the mechanical systems to do that ultimately, no matter what building we're in. But for Passive House, thermal comfort is a prime driver of the quality of the building, like really good thermal comfort, and that we're not over reliant on the mechanical systems, that the architecture of the building is really going to deliver it. On the code side, we see improvements on indoor air quality, which is wonderful, and taking that more and more seriously. In Passive House, we want to lock in healthy indoor air quality. It's kind of one of those non-negotiables. So Passive House, you can see, is kind of trying to establish these points of quality and want to hit them, rather than just giving credit for doing better, which is important to do better. But on the energy code side, more efficient, more durable, affordability, important. Of course, it's important. Passive House will just say we want to make it energy efficient and we want to make it durable, not just more durable. We'll get into under the hood on what the implications of these slight uh, emphasis is. Affordability, they're both about affordability. Passive House is thinking about it slightly differently, and hopefully we can dig into that. We will to some extent. Um, Integration of the building components is everything in driving performance. And we see that in the performance method in the code, appreciating that and bringing it further. So we see further integration. We see that being leveraged more. Passive House, again, it's everything. We want to leverage it to um, the optimal place that we can get it to. Flexibility is important in terms of demand and how the building is going to respond, needing power, needing heating and cooling through the seasons. The codes and everything are to a certain extent leaning on tech in a way through the mechanical systems, through controls, through alternate generation, batteries, all these things are good. But Passive House is saying we're going to build flexibility in a way through passive buffers. We're going to build a quality building that isn't so reactive to the environment. So we have flexibility in being able to cool or heat when it's not the most expensive. Uh, and it's not about technology working correctly, which sometimes it doesn't, to make that happen. And then perhaps I don't mean this to sound as harsh, maybe as it comes across, but on the code side, where we're all pushing for an electric future, many people are, and certainly in California and New York and Massachusetts and other places across the country. Um, we'll talk about this too a little bit, where the issues of what do we mean by optimized and going all electric and being net zero, and how are we using the electric grid. Passive House has thought about this pretty intently and has developed metrics to try to improve on how we've been thinking about it before. So one's not wrong and one right, but one is definitely Passive House is trying to be more rigorous in many ways, and related to the building. Now, Passive House is voluntary by and large, and the energy code is not. And so there are lots of reasons why things are shifted one way or another. Passive House, we see codes moving towards Passive House in New York. Some of the insulation levels and things are getting uh, quite close. There's still a bit of daylight to cover there. In Massachusetts, they've actually mandated Passive House certification for multifamily buildings over 10,000 square feet, um, in the jurisdictions that have adopted them. So the big population areas in Massachusetts have essentially adopted this mandate, or a related TEDI mandate, thermal energy demand intensity, which is basically a heating and cooling metric, much the way Passive House is driven to make sure that we're hitting low energy outcomes. So Passive House is very much, we're very hopeful to have Passive House um, be recognized as alternate compliance pathways, and be recognized for the value, and we can talk about this, that deserves perhaps a little bit more incentive than conventional construction to get the value that one can with Passive House construction. So enough about all of that. Let's talk about Title 24. And then we'll swing back around, and I think it'll start to make sense, hopefully. Um, so it became effective. The 2025 Energy Code became effective in January 1 of this year. Um, and so it is out in effect. Uh, it's comprehensive updates, statewide minimums, generally more stringent than previous cycles. looking to do greater to provide greater uniformity, expansion of prescription requirements. One of the more interesting things in terms of from a passive house perspective is that it's establishing an energy budget, a literal budget, rather than a rating. So it's not this abstract thing anymore. It's really connected to the energy use and to the dollars and cents, which is much more in the wheelhouse of how passive house is going to think about that. Increase building energy efficiency cost effectively. And we can kind of debate what that means or how that might work or not work, but definitely, everybody's concerned about cost effectiveness and affordability. Increase heat pump usage, which is an interesting thing to prioritize as a piece of equipment. In the realm of electrification, it makes sense as being the dominant and useful form, however, or of course, and promote demand flexibility, solar PV, battery energy storage systems, improved ventilation systems and indoor air quality, IAQ, another key aspect that makes passive house ears perk up. So we want to, along with those things, reduce greenhouse gas emissions. The big ambitions, save billions of dollars. Those heat pumps, big numbers of heat pumps, and saving water as well. Very important. So I know in the Tri-County region, the climate zones are 4, 5, 6, 9, and 16 were appropriate. We're trying to highlight that a little bit. Kind of develop this key to go to be able to talk about what was that has been eliminated, what's new in terms of provisions, what was and remains existing, and that's probably the least exhaustive of it, and then existing but modified in the new code. And I'll try to call that out. These ACE resources is one of a number of resources that are really helpful to get the overviews of the code and get some direction. Starting with some of the metrics and terms, getting rid again of the ratings, so the energy design rating and this time-dependent value, and moving towards metrics around long-term systems cost, which is present value of the energy system over the 30-year life in dollars per square feet, based on each hour of the year in each climate zone, energy type, building type. So it's quite specific. And then there are two types of that. The efficiency, which is going at the cost and effectiveness of core building systems and costs, whether they be windows or insulation, or heating or cooling, and then total, which adds the costs to include on-site renewable energy generation as well as batteries. Source as um, uh, as a metric has switched to actually being a marginal fossil fuel use at the building, or time-dependent system loads, and again, lifetime average kilobtus per square foot year. Losing the HERS rater nomenclature, moving to the energy code compliance rater, perhaps a housekeeping there in terms of moving from one part of the code to another, maintaining the basic responsibilities there. Peak cooling is added, and really looking to address the cooling demand at that peak time between 4 and 9 p.m. Single family, applied to the performance methods. So we're putting a cap on that cooling. You can't take advantage of balancing it and stressing the system. Battery ready energy storage system is further um, developed from the energy storage system. So let's then move to the idea of the performance path versus the prescriptive path versus what are mandatory requirements. And the mandatory requirements are backstopping both the performance and prescriptive paths, but I think ultimately the performance, as you're trying to trade away things for an optimized outcome, you can't drop below certain um, levels of performance, certain values. So on the performance side, you're calculating, you're doing models, and you're looking at the long-term systems costs, source energy, the peak cooling, and playing with these factors to optimize it. We like this from the passive house point of view. We're about optimization uh, and optimizing the performance and these kind of trade-offs between the different elements of a building, giving us that greater flexibility, especially when we're looking to cost optimize. Interestingly, the performance method is going to allow us to use fossil fuels for space or water heating. Um, and we can optimize with additional credits for variable capacity heat pumps and heat recovery ventilation now. We do get credit for greater air tightness down to 2 ACH 50, insulation and other efficiency measures, um, which is fundamental. Prescriptive is the recipe, is the checklist, what you're going to do. We see tighter window requirements, both in the U value and the solar heat gain coefficient. Uh, Balanced ventilation has new requirements attached to them. It's less flexible but simpler. The big switch here and that push for heat pumps is that no fossil fuels for space or water heating. We're going only to heat pumps. And that's going to trigger some further inspections and verifying the refrigerant charge. We have expanded roof insulation requirements or applicabilities, and there's no optimization incentive. Pretty straightforward there. So let's go through and just give some of the basic changes here and updates with the code. So on the mandatory side, which is really low-hanging fruit, we're going to R15 from R13 in a 2x4 and to 21 from 20 in a 2x6. In metal frame, we're going to have a layer of continuous insulation over that. Nothing all that ambitious. I mean, this is minimum requirements. On the Windows U factors, it's tightened a bit to 0.4. And however, you have exceptions for fire resistance requirements. Air tightness is assumed at 5 ACH 50. Air sealing is required and 3 ACH 50 is the target, but since actual air tightness is not required, I think you're either testing it and knowing what you've gotten, or they're assuming 5 ACH 50, and hopefully it's that good. And we can all go talk about that in a bit. A multifamily metal frame, the walls need more continuous insulation depending on the climate zone. There's no reason to go into all that. Unit air tightness has been added, which is interesting. Passive house as a standard does not look at unit by unit. It can be very important, and it's nice to see that there, but it's looking at the whole building and not necessarily a unit by unit, unless you're retrofitting perhaps by unit. Entry vestibules are a big addition in the new code for multifamily buildings, with many exceptions. Ventilation, based on ASHRAE 62.2, the balanced ventilation with heat recovery is not mandatory, but if you do use it, there are new mandatory requirements that the filters and cores have to be accessible, that the intake and exhaust design requirements are more rigorous in terms of, protecting them from weather and being at certain heights and so forth. Um, the fault indicator display devices, we need to know there's an issue. Really, all this is about just maintaining the performance, right? And maintenance. And you get credit if you're using an HRV or ERV in the performance method. In multifamily, only supply or balanced ventilation is allowed. I'd be interested to hear what people think about supply only ventilation. Um, Balanced ventilation required for 1 to 3 stories in climate zones 1 to 15. Um, yeah, we can talk about ventilation again when we come back around. Moving along, the heating sizing mandatory requirements per ACA manual, no limit on cooling capacity in the mandatory um, or yeah, mandatory requirements. If heat pumps are used for space heating, mandatory for prescriptive, verification of refrigerant charge by the rater, and enhanced controls that include display outdoor air temperature and others. If gas space heating is installed under the performance pathway, it needs to be heat pump ready. We need to have space for the heat pump and the associated equipment and the circuits for it. And that means, in general, as you see electrification ready requirements, that a whole series need to be in place with the infrastructure of the building. Heat pump hot water heaters, mandatory and prescriptive. There's a bunch of new definitions talking about all the different types of heat pumps. We'll go into it here. There's split of different type, as well as integrated heat pumps. And what we see on the upper right here, so this is integrated heat pump hot water heater in a closet with a ducted intake and exhaust, and um, integrated, not ducted. And then a split system where you have the condenser outside, the water tank inside. Where they're integrated and inside, if they're ducted, an R6 in insulation on the ducts. Non-ducted is then lends itself to the volume of the space that it's in. And I would say the more and more I read about non-ducted integrated heat pump hot water heaters um, inside a living space, the more nervous I get. That heat pump is, well, it's loud to begin with, but it's also just cooling down the place. And depending on where that cool air is coming on, if it's coming onto a surface, you need to be really careful about the installation of it. And if the humidity levels are there, it's coming through the louver and whatnot, we want to make sure we don't have dew point action there and having condensation being forming in our utility closet because there's not enough space to get the circulation and the heat um, uh, that the water needs because there's not enough space. So there's more and more coming out on that, and it's all, you need to be careful because the efficiencies of the integrated heat pumps will drop as the air temperature inside the closet drops. So I would the gist that we're seeing is you want to be pretty conservative about what you're doing with these heat pump water heaters and make sure you have lots of space, like a room, a decent sized room that it's in, a utility room, 10 by 10, larger, not a closet. If it's ducted, great. We like to see ducted. Um, Filter access, good things like that. Backup heat source, electric element. Gas instantaneous hot water heating is no longer allowed. And below 500 square feet, um, instantaneous or tank point of use is allowed. So, um, and then controls. For unducted, yeah, a garage it would be perfect because it's not even conditioned space. There's a question in the chat. For unducted heat pump hot water heater, is a garage enough space so it doesn't get too cold? Yeah, no, that would be ideal. You still want to make sure that you're not dumping that cold air outlet should just be going out, pointing towards the middle of the space and not like up against a wall or something. If gas hot water heater is installed, again, space and circuits for future heat pump. Uh, let's see, electric ready and up the ampage, right? We need to have um, 30 amps now for the hot water heater. And battery energy storage system, solar calculations are modified and updated. And even commercial kitchens now need to be electric ready if they're not already electrified. I didn't mention, which I should have going in. I don't know. I was just ready to jump in. So we have our national conference coming up, the Passive House Network. It's unfortunately for you all in California, it's on the other side of the country, but it's a great reason to come east because it's going to be in Hotel Marcel in New Haven, Connecticut, and it's a certified passive house retrofit of a hotel. We may have a picture of it later in the presentation, and it is electrified and it has an electric commercial kitchen in it, as well as other amazing things. So beautiful brutalist, classic brutalist architecture, and should be a lot of fun. That's June 4th and 5th. So that's that little aside. Prescriptive assembly, not a lot of changes here. They're just tightened up a bit, right? So we've got a U value for the walls above grade 0.048 in our 4, 5, 6, 9, and 16. Not very climate specific in terms of what's happening there, but it's about an R21. We have ceiling below the vented attic at R30. Then we bump up to 38 in climate zone 9 and 38 as well in 16. And an unvented cathedral roof is now addressed in climate zones 1 through 16 at R38 as well across the board. Multifamily has new slab edge insulation requirements to take a look at. On the Windows side, the U values have gotten slightly stricter and solar heat gain coefficient values have been added. In climate zone 5 in the Tri-County area, there's no requirement as well as in 16. Multifamily U value as well has been addressed in a number of climate zones. Let's see. And then we have the WUI, the fire resistant compliance exceptions. In ventilation, prescriptive, if we have continuous ventilation, balanced ventilation, minimum heat recovery of 67%, fan efficiency of 0.6 watts per cubic feet minute. Again, the accessibility, we need to be able to maintain it, and we need to have indicators. The outdoor intake needs to be accessible and weather protected. So great things to just make sure it's going to operate well. And then back to our peak cooling load under the performance, we need to make sure we're not blowing out the cooling load when everybody else needs cooling as well. So we're capping it at this stress point between 4 and 9 p.m. with the battery um, system, there's defined as this self-utilization credit that allows greater optimization and can actually allow you to have a smaller solar panel installation and meet the requirements and still have that resiliency that we want to see with the power flow. Air tightness. Um, let's see. The performance approach is going to require an audit and a blower door test. It's assuming 5 ACH50. We want to get it down, as low as we can go. Passive house goes very airtight. And yeah, these really have not changed. It's more, I guess, a matter of the name of the energy code compliance rater as opposed to hers. So in brief, in terms of the code update that started on January, came into effect January 1 of this year, it's really going towards this budget rather than a rating metric, which we see as being very exciting, or I do. We have the update to minimums, uniformity, things we talked about before, the demand flexibility. Want to emphasize that, improve ventilation, IAQ. Um, are you required to do a blower door test for the single family projects in this new code? You're required to do blower doors if you're claiming a credit, I believe, in the performance pathway. So if you're saying, oh, we're at 3 ACH50, you're going to need to prove that to be able to get them to buy your energy model. If you don't do that, if it's prescriptive, or if you're just assuming it's 5 ACH50 in your energy model, then you wouldn't need to do a blower door test. Um, and then based on this code, if you want to do an unvented cathedral roof for fire reasons, you're then forced to do a performance-based approach, question mark. That may be true. I'm not. Unvented cathedral roof now. No, it's now allowed in prescriptive. So you're allowed to do it. You just need to meet certain things: continuous rigid / air impermeable insulation directly above or below the roof sheathing. Vapor permeable, vapor ports, or vented cold roof can also be possible. So if you're meeting certain more stringent requirements in the prescriptive path, you could also do it. Um, I'm not sure which thing you were referring to, Graham, in terms of being a huge change to the code, but let me know, and I definitely would like to emphasize it.
The whole approach here. It's very, I mean, it's moving toward real performance.
Uh-huh. Yeah, well, let's yeah, I mean, certain things definitely. I'd like to take that apart a little bit. Let's when we come back around and compare the two, maybe, and we can take a look. But I don't you um uh, I look forward to you articulating that further. Um, so prescriptive windows, uh, stricter U values, solar heat gain coefficient limits, multifamily, um, uh, similar um, as before, updated, but um, prescriptive ventilation. Oh, what am I doing? I was there, wasn't I? Okay, so we just finished the code update. Let's go to passive house introduction. And I know there are a bunch of passive house people here, including Graham. I'll try to be brief, but as well, to those that are new to passive house here, try to give you a strong feel for it. And I think hopefully you'll get a stronger feel when we start to compare and contrast maybe, and we can have a good conversation there. So passive house is a building standard. It's a concept. It's an idea about performance, about energy efficiency. And they provide certifications so that you can, clearly be recognized as achieving this level of performance. It can apply to new buildings as well as existing buildings. And it's completely a performance-based approach. We need to use an energy model and calculate it. That's where the optimization comes from. You don't know what you've really got unless you've calculated the energy balance. And we can talk more about that. Focuses on mastering the drivers of building performance. And I'll unspool that as we go. So back at the beginning of the modern era of passive house, it was built on a whole series of building science innovations in Europe and Scandinavia, including Scandinavia, in the US and Canada and so forth, coming together. And Wolfgang Feist, who founded the Passive House Institute, has this quote. He says, "I was working as a physicist. I read that the construction industry had experimented with adding insulation to new buildings and that energy consumption had failed to reduce. This offended me. It was counter to the basic laws of physics. I knew that they must be doing something wrong, so I made it my mission to find out what and to establish what was needed to do it right." And so here you see the conundrum. We're investing in efficiency measures and things that should improve the performance of the building, like insulation, but not necessarily seeing the results. And hence, these improvements really in the conventional scenario can really be quite discounted because nobody believes that they're actually going to do their jobs. And the engineers are oversizing mechanical systems, or maybe they're not oversizing it because of the ultimate performance, but certainly to what could be, they're oversizing them. Passive House is trying to correct this and right size everything. And I like to compare it to cooking, right? So like this wonderful book pointing out that salt, fat, acid, and heat are these basic drivers of great cooking. And if you can master these drivers of cooking, you can make wonderful meals, these elements of cooking. And Passive House is asking us to do that same thing with buildings. So the first passive house, the first modern passive house, I should say, that really kicked things off was completed in 1991. There's 4 flats. They're basically 1, 2, 3, 4. A small multifamily building, if you will, but they're all individual units. Was completed as a physics experiment, essentially, to see how low they could go. They had to customize the windows. They needed to customize the ventilation system. And out of this, they produced a very high performance building. And the story goes that Amory Lovins from the Rocky Mountain Institute visited and was very excited by what he saw them achieve and was very encouraging to them that this was scalable, that this should not be a laboratory so much as out in the world. And Wolfgang Feist and his team developed and codified the methodology, developed the energy models, and the passive house system as we know it in certification today. And so what's interesting about passive house is it is an energy efficiency standard. but it's not the end of the story there. Energy efficiency is serving purposes of climate mitigation, but it's also serving climate adaptation. It's serving a wide range of benefits, and we can get comfort, better indoor air quality. It's more resilient. And we see people with higher levels of satisfaction um, there. From the owner's side, you know, it needs to be affordable in terms of an upfront cost, and we can talk about that and what that means in the different situations. But it's a higher quality building that you're getting, and we see again and again reduced maintenance, reduced callbacks from the builders, and you're getting perpetual energy savings, happier occupants, lower vacancies, higher asset value, and ultimately what may look to people newly coming to passive house as a higher risk proposition is ultimately a lower risk investment and is really protecting you for the future, which we'll talk about. Fire resilience is one aspect of this too that has been talked about more and more, and particularly since the Marshall Fire first in Colorado just over 3 years ago, and then of course in Los Angeles last year. And what some of the qualities of passive house don't make the building fireproof. Nothing's really going to do that, but aspects of it can support fire resilience. And we'll talk about that in as we go through different aspects. We've developed resources as an organization. We had a design competition last year to support the rebuild effort in Los Angeles. And we're coming out with a catalog now that highlights all the submissions to it, which is fantastic. A wide range looking at craftsmen, homes, Spanish colonial revival, mid-century modern, contemporary, really trying to have passive house and fire resilience and vibrant architecture to help bring these communities back stronger. An interesting thing too, we circle back on this, is how we're looking at the power supply. So now we still have quite a bit of fossil fuels in supplying the electric grid, but it's going more and more renewable. And as we push towards the goal, hopefully, it's not a dream to be 100% renewable, that how the building is composed and operates has a profound effect on its relationship with the grid. So while emissions are incredibly important, the primary energy emissions, source energy emissions from fossil fuel production is becoming less important, and how we're using an all renewable energy supply more important. And to future-proof the buildings, Passive House is saying, we need to know what the quality is in terms of that future power supply, because what's happening in the weather, how the rivers are running, how the wind is blowing, how the sun is shining throughout different parts of the year, and what is that final energy use going to be throughout the year? When do they align? When do we have simultaneity and we have practically zero losses? Where do we have short-term losses, like through a day-to-day using hot water or peak plug loads, or things, offices coming on and off? And then when do we have long-term storage requirements, seasonal storage requirements, so that all that energy, renewable energy that's produced in the summer, is available in the winter when we have less supply and higher demand, at least for the foreseeable future. And then summer demand will top it. And maybe, depending on where you are, it may now. But we need to rectify the seasonal storage, and those require bigger losses to do that. Certainly regionally, it's always going to be at the end of the day, peak in the wintertime, even if it feels like it wouldn't be. And so part of that is looking at our typical net zero single family home, where we have a great production here, but as we can see, the production is not aligning with the demand. The all electric home, the peak demand is going to be in those winter months, typically, not necessarily always. And what we have is a gap overall on a regional basis. And if we can crush the wintertime energy use, we can reduce that gap. We can reduce the amount of energy production that we need to do. And so it becomes not so much a matter of net zero as it is a matter of tuning to the grid capabilities and making it as optimized as we can. So in homes, possible across the US, including Los Angeles on the lower left. We see it in affordable housing at different scales. These are both in New York. University in Maine on the left, and 2 public schools on the right in Brooklyn, New York. So we see a variety of uses that are possible. And so, I don't know if this is, did I misplace these? I'm not sure. I think what we're doing is going deeper a little bit, maybe. The goals of Passive House in terms of this greater efficiency, or I just misplaced it. Let's see here. It's coming next. The goal of energy efficiency is actually driving greater comfort and health, which is driving energy efficiency. So Passive House, we talked about a wide range of things in relation to Title 24. We can boil it down a bit more to that thermal comfort, hygienic conditions, efficiency, durability, affordability. The international standard on thermal comfort. So what is the temperature of that glass on a cold winter day? What are the temperatures of the surfaces around the room? This is what is driving the performance levels of the insulation. It's not, oh, we can make up, it's not that crazy to make up the rest with mechanical systems. We want to really bring it down and make it as even as possible within a pretty tight band. So an idea here is to decouple power and performance. We expect that with our electronics. Our phones are way more powerful and they use a lot less electricity. Same thing with the TVs and desktop computers. In a typical leaky home, let's say in this example, we have the losses below the line of equilibrium and the gains above the line. We've got a little bit of solar, we've got a little bit of internal heat gains from the people, the equipment, pets, so forth, lighting, and we need to make up the rest to balance this out with an active heating system. Modern homes, and we see the codes pushing these downward and tighter. Passive House is just saying, we know what we need to do. It's not that much more, and we can make it affordable. Let's just do it. Let's go there. We're done, and we can maintain that low energy state. So it's pushing that down. Now, it's not a passive solar home in the historic sense, what we think of the 70s, where we have huge areas of glass, we're overheating. the home. We have big swings. We want things to remain as much in balance as possible. And we're not looking at relative improvement. We're looking for fixed targets that are actually going to deliver it. And so there are just a few metrics, which is pretty amazing in terms of, the basic physics being able to deliver this wide range of benefits. Of course, there's more to it in the methodology and delivering it, but we have a heat demand number that's quite low. We have a cooling demand number that can vary a fair amount based on the dehumidification needs. That blower door test, we're talking about 5 ACH 50 with the California code that's assumed you may be able to come down to 3. The target's 3. You can get credit down to 2 ACH 50. Passive House is saying you need to be, for new construction, a minimum of or the maximum leakage that you can have is 0.6 ACH 50. So it's a whole nother magnitude lower. And it has huge effects on the comfort, on the energy use. And then we have the overall energy demand per square foot year to lock in the overall energy demand. The energy credits in the code on the performance pathway, like higher insulation levels, better performing windows. You could put into the energy model, CBEC, the air tightness, and have that energy balance.
So are those credits that you're using in order to hit the required metrics in that performance model? Is that what the credits
Yes.
are? Okay,
Yes.
got it.
Yep. So what are the drivers? I kind of held back from this when we had the salt, fat, acid, heat. In Passive House, there are 5 basic principles. There's continuous climate-specific insulation levels, thermal bridge-free connections, air tightness, high-performance windows and doors with solar protection, super important, where we have hot summers, and high-efficiency heat recovery ventilation. And we'll unpack all of this here. Okay. So the predictability is the thing. If you're going to optimize, you really need to know what you're getting. Now, there's going to be variability. There's variability just in life in terms of the job site is not a laboratory. It's not a factory, even if we make a bunch of the house pieces in a factory. People don't live the same way and don't have the same habits or likes in terms of temperature or power use and whatnot. So there's a certain amount of variability, but we want the variability to be tight, and we want to be able to optimize the systems. We want to have a strong idea about the building really performing well in a range of climate conditions, from freezing cold winters to broiling hot summers. Places up north that are used to the cold now have massive, really dangerous, life-threatening heat waves. And, the buildings need to be able to buffer and perform in those conditions. So you can do a great building in all kinds of ways. What these graphs are pointing to is that a code-driven building, you can have a really good performing building, but a really not so performing building. And they're kind of all over the place. There's no system there to really lock it in a tight way. Other sustainability standards like LEED, and LEED does a lot of great things around sustainability and has done huge service in transforming certain aspects of the industry. But energy performance has not been, let's say, its brightest spot in terms of performance. And so you could also end up, and there's been plenty of reporting on LEED Platinum buildings that are terrible in terms of energy performance, and really quite shocking. And that's not to say you shouldn't do it. It's just, it's not going to lock it in. Whereas Passive House is really, really focused on the energy performance. And if you certify it, you're really going to be hitting the marks. Uncertified passive houses are a bit of a crapshoot. Often what happens are teams that have done several certified passive houses, and they've kind of gotten their sea legs and they know what they're doing, and they're still working with those same building types and systems and whatnot. They, they probably don't need to certify anymore. They know what they're doing. They can hit the marks. But too often, folks really don't have it down yet, and they can benefit. It's almost like an apprenticeship on the job, a graduate school, you know, a time to really get those fundamentals down. And with that, we see a really tight band. And so, like the house that I did as my first passive house, which I was kind of, really nervous about because the family was spending a lot of money renovating the home, and all our neighbors had 12 to 15 tons of air conditioning installed, and I was suggesting we install 3 tons of air conditioning. And it can get pretty hot in New York, and right now in New York, it's been like 7 degrees the last several days, so quite cold. And I'm very happy to say that the house has performed, and it's been I don't know, 12 years now. So very happy about that. And so this predictable performance, the calculation of the performance, is absolutely essential. And this is what helps get us toward real affordability. And, construction is not affordable in the first place, and housing isn't affordable in the first place. So it seems like pie in the sky to be talking about really high quality housing and buildings. But by gosh, if we're spending so much to begin with, if we can tweak it and really lock in good quality, it's worth, even more. So on the left is a graph. I want you to ignore the dollar per square foot amounts. They are shamefully low. They are not valid today. This was quite some time ago, and it's in Pennsylvania, in the middle of Pennsylvania mostly. So the point of this graph on the left, so we have the dollar amounts here on the left and the size of the multifamily building. This is affordable housing in Pennsylvania. The black dots are conventional buildings, multifamily affordable housing. The blue dots are passive house. The takeaway here is not the price. The takeaway is that there's no direct correlation between passive house or conventional and price. To me, that says, and in talking with others, there's a lot of things that go into the cost of a project, a lot of cost drivers, and passive house need not be that it should not be that driver of the cost of the project. And we see where teams are optimizing and working from day one to hit these performance targets, along with other, as a basic programmatic item, that they can really cost optimize the building. And so some basic things to do that. From day one, have it in the program. Work with a certifier. So the certification is going to make sure that the owner gets what they paid for. Again, you don't have to, but it's a much more of a crapshoot when nobody's really holding your feet to the fire. Get some training for the team and optimize from the start and stick to it. There are some reports out there on costs. Admittedly, most of the data is on bigger buildings, on multifamily buildings, and affordable housing buildings where the budgets are more available. Perhaps ironically, the toughest building type to hit the numbers and make work is a single family home, despite the name of passive house. The bigger the building, the easier it is to optimize, the easier it is to hit the target numbers. And so in a single family home, you've got your work cut out for you, but it's certainly doable. We see it happening. Graham, who's speaking before, is doing it in California. There are people doing it up and down California as well as across the US. So certainly doable. So let's talk about Passive House in Title 24. And we're going to dig more into each again. So we have this kind of setup. I don't know, it's not exactly a straw man, but it was something to get the kind of back and forth conversation going between, and not, not to pick on Title 24, it does a lot of things great. And Graham, I'm interested in hearing more of your thoughts. Moving in a good direction and versus kind of where Passive House is coming from in terms of targets, in terms of how it's thinking about thermal comfort, in terms of what it's promising to deliver in indoor air quality, what it expects and from energy efficiency, both in terms of hitting the numbers and what results from that, the durability, the affordability, how we're leveraging integration. I think one thing that's interesting, and maybe talk about this, is we do see the greater integration being able to be leveraged more. And I think maybe that's what you're alluding to, Graham, in terms of the path towards Passive House. But my sense is, and I'd love if somebody else has more experience with this to chime in, but they're still leaving quite a bit on the table because, like Wolfgang Feiss observed, we may be doing some of these things, but we're not necessarily getting the value for them. Where Passive House is really leveraging that integration in a bigger way. Code is improving in all kinds of ways, in passive ways in terms of the structure, but really bringing in tech in a strong way to get that performance and that flexibility. Passive House is looking at the passive things first and foremost, kind of building a buffer into the structure of the building so that it's not so reactive to the environment outside. And perhaps unduly harshly or not, I don't know, each time I read it, unoptimized all electric futures. Just there's more work to be done. I'm sure there's more work to be done with Passive House too, but it's definitely looking at that end game kind of in a clearer way, perhaps. And Passive House doesn't have politics to deal with, doesn't have an electorate, doesn't have regulators and all the rest of it to deal with. They're dealing with science, so they can afford to be perhaps a little bit more idealistic about it. I don't know, but we see it. We see them happening. The buildings are happening. So one thing, and I would be interested to hear what people think about this. I saw this graph on the PG&E residential electric rates. And there's a lot of ink that's been spilled in just the last months. California has been hit by big increases in electricity rates, Massachusetts, New York, a whole bunch of places. I actually did a blog post recently on the the rapidly increasing value of a saved kilowatt that it's not as cheap as they were last year. And which way is the energy going to go? I just stuck 3 arrows on this graph. We see it pretty flat, pretty regular for the decade before 2021. And it's not exactly flat, but it's like closer to inflation. And then it kind of rocketing up. And I don't know exactly what is driving it. We know that electrifying everything is certainly having its role. The climate disasters, the wildfires, the deep freezes, all of that is having an effect. The constraint that the energy system operate under, the need to invest in infrastructure upgrades is driving it. There are a whole bunch of things that are driving it. It's not a simple problem. And so if we're looking at any scenario here, passive house economically can work on this low scenario. We can make numbers work for that. Well, what if it's, following the last couple of years, which is a rocket ride? That's a huge problem. It's like healthcare, non-affordability. What are we going to be able to afford? And then let's split the difference. It's still kind of nuts. I do not have anything scientific analysis here about this. I think it's more thought experiment in terms of what kind of futures are we preparing for? Yes, data centers. That was one as well that I was thinking I meant to mention. Absolutely. Big tech is not going to save us. So 5 principles, the drivers, comes back to these things. So let's talk a little bit about the benefits and of passive house, how we think about passive house, and what it's delivering. And there are a bunch of intangibles or things that we can't really place a monetary value on. This quote is real. Somebody who was living in East Harlem in typical conventional affordable housing and then moved into the new passive house building and said, we haven't had to take our child to the emergency room with an asthma attack since moving in. So a complete change in these people's lives, which is worth a lot. And the family that I renovated the house for, they moved from another building in the neighborhood in Brooklyn Heights, well-to-do family, no doubt about it, the other end of the spectrum. One of their children had real respiratory issues as well. And once they moved into their new passive house home with air tightness, with good ventilation, their son no longer had those problems. So those are anecdotal. I don't know of any thing that has a large scale. I would love to see universities pick up research dollars. I'm a runner, and I see so much spent on researching running. It's unbelievable, and I'm like, oh, let's get some of that research money and do high performance buildings and passive house buildings. Thermal comfort and resilience. So we want to be comfortable and we want to be resilient. This quote, the house maintains a steady temperature so well that it wasn't until many weeks into the winter that we realized the heat was not even on. I will say the disclaimer is that quote is not attached to this house. And I have to say that because I know a bunch of people know this house up in the Rocky Mountains. And this house is in pretty extreme weather. I had the good fortune of staying over there one night. Incredibly comfortable, but it has this buffering again, where it has this flexibility where it's going to hold the heat, hold the coolness in the summer, like a great cooler. You want to keep the ice cold or your coffee hot. That's what a passive house is about. And we're going to do that with specific insulation levels. So if we're in a more extreme climate, we're going to have a heavy parka. If we're in a less extreme climate, we can be a lighter. In California, most of California, it's easy. And we're just talking about the design competition in Los Angeles. The insulation levels are not a problem. You just need to put it together in an integrated way, and you have really high performance. And one of the examples at the end here will be the house in Pebble Beach, which we'll look at some of the values and details. Yeah. So thermal bridging is something the code doesn't deal with at all, generally speaking. Bigger commercial codes and more progressive codes will take it on, and that is changing. But what we're talking about for residential construction, essentially ignored. And many buildings at those construction junctures, there's little thought given to how the way the details are coming together, the way the framing, the structural elements are coming together, the insulation is coming together or not, is undermining the performance of it. Right, exactly, Preston. So when thinking about R15 walls, is the insulation R value effectiveness considered, right? And the different types of insulation that you may be used. How much do we need to discount that insulation? If you just have bad insulation between metal studs, you have to discount it 50% right off the bat. And then what we're talking about is, where the wall, so we've got all this problem with the studs and the floor framing, and then we've got the corners and where the roof hits there, and you have miles and all the window installs, you have thermal bridges there. This thing's a big radiator to the world. You're heating or cooling your yard. It's not that efficient. We should just be heating or cooling the space that we're in. More like a Yeti cooler here. Let's maintain that energy. And so Passive House is saying, we're going to look at every one of those junctures and we're going to build it well and we're going to put it together and we're going to know that under the more extreme design conditions that we need to comply with, that we're going to maintain temperatures on this interior surface that are comfortable, that will prevent mold growth, condensation, and illnesses that come with that. It's going to maintain close enough air temperature between your feet and your head, and further up, we're not going to have a huge stratification of the air where convective currents are created, where we need to have perimeter heating and cooling. In a passive house, because the windows are performing so well, we can pull the heating and cooling back to the core of the building. We still need to deliver it to the perimeter spaces, but we don't need to deliver it at the windows. It needs to be in the space. And so there's specific comfort criteria, and there's specific calculations that need to be done to ensure that regarding the surface temperatures. The surface temperatures are everything in terms of giving a sense of comfort in combination with wind speed and humidity, activity, and other things. But architecturally, we want that container to be well under control. And the details are going to be a major driver of that. The windows are super interesting. So not only in terms of themselves, but how they're installed is going to be a big deal. They are continuations of the insulation layer. So we're often seeing triple pane as the airtight layer. Often they're triple gasketed. There tend to be, really quite thermally broken. This is a hefty one. There are quite thinner, flatter profiles. More and more options are available today. 15 years ago, there was like a half a dozen suppliers. Today, there are dozens of suppliers and American manufacturers that are making the windows. The insight here is that the frame is really the crappy part of the window. And Passive House, unlike the American rating system, is not looking at the entire window, but looking at it in its component parts. So it's not excusing the frame because the glass is that much better. The window really suffers if we have a lot of frame to glass. You see the U values rising as the windows get smaller. As they get bigger, they're higher and higher performing, all things being equal. So fewer bigger windows than a lot of little windows is going to be more economical and more comfortable, higher performance. Again, that temperature, conventional, we have high temperature change at the surface here. We need to provide mechanical heating and cooling. We're close enough, we're not going to have that discomfort, which is nice. And so in most of California, well, much of California, you're not actually adding that much insulation on the walls. But even in more severe climates, you're adding some insulation. You're taking away a little space, but you can actually use the whole space. You can actually sit by the window and be comfortable. Our house can hold the temperature in summer too. Utilize natural ventilation when cool at night and benefit from shading strategies. So a hot climate thing has been kind of like, I don't know, the boogeyman of passive house, where people say, oh, well, it came out of cold climates. It doesn't work in hot climates. It doesn't work in hot and humid climates, or there's something about these standards that are ever working around the world. They don't work in my hot and humid climate. It's not true. The physics are the same everywhere. It's a matter of applying them rigorously and knowing what's what. And so dealing with overheating, it's true, traditionally in colder climates, they didn't have to deal with debilitating heat waves. They could just rely on overnight cooling in the summer, or not even. It would just be cool enough that air conditioning was not an issue. So it did not develop with air conditioning in its core of kind of methodology. But in the last couple decades, as climate change has really changed everything, and we have heat waves where there never would have been, cooling is not just about comfort, it's about life safety, and you're going to need it. So it's about minimizing it. And the summer cooling strategies are super important. So passive cooling strategies. And that means not over glazing. It means providing shading and opportunities for natural ventilation, and making sure our interior heat gains are as low as they can reasonably be, that we're not wasting internal, we're not wasting, domestic hot water heat losses through the distribution, which is essentially a radiator inside your home, unnecessarily heating the inside of the house that you then need to air condition. So you're losing it on the hot water side, and you're losing it again having to cool it. This house is in Boston. There are actually 3 of them. They're all, each slightly different. 3 families, 3 different families unrelated in them. Amazing stories and performance. Yeah, so as Graham was saying, the performance level, take the code, add the rigorous air tightness, the high performance heat recovery ventilation, slab insulation, and thermal bridge mitigation. It's really tweaking. A lot of this, people are recognizing it. I don't know, I think there's hesitation to really screw it down. We get it. People like windows, and you like to feel like you're outside when you're inside, and there's a great architectural traditions, particularly in Southern California, around that, indoor-outdoor living. But in terms of power and controlling the thermal comfort inside, it can be incredibly wasteful. And if there is a way, so on the left is a conventional fancy home with way too much glazing and little solar control, and a passive house on the right, not in California, although it could be. It's in Spain, and using, considered big glass, having those views, but also providing the shading and differentiating and creating that. you can almost see the energy balance in the building on the right and understanding how that's coming together, where the one on the left is just fireworks going off. It can be as simple as recessed windows shade. This does not have to cost a lot of money. And that detail, how it sits, the architecture. It could be the landscaping and its relation to the building. Just hope you have control over the landscaping and you're not relying on somebody else's tree to maintain your indoor air temperature. There's all kinds of architectural examples of using shading in the architectural design. And I think that's one of the great things that, or really important things that architects really have yet to embrace. You see shading elements deployed on buildings kind of half-heartedly a lot of the time, where they have some relationship to their orientation, but not necessarily entirely, or they may do something, but not enough, perhaps. And there's huge possibilities. Of course, pre-war, there was no central air conditioning or air conditioning to speak of, and you had wonderful architectural expression and tactics to provide shading, the vernacular architecture, and modern architecture for that matter, brutalist and otherwise. Airtightness and resilience. So to come back to this fundamental thing about airtightness, and Passive House is so fixated on thermal bridge free design to get that thermal comfort and airtightness to help with the energy, but to help with that indoor air quality, keep the outside pollution out. And there's no better example of that than having to get through smoke from a wildfire. After the Marshall Fire, uh, 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 a Passive House practitioner and Colorado resident there, smoke infiltration from the Marshall Fire destroyed my neighbors' homes, but our Passive House kept smoke out and our house undamaged. I mean, that is quite a statement, and there's a lot of value built into that. How you calculate that and how the insurance companies could find value in that, or the market or the government, and incentivizing really airtight and tested construction seems like obvious questions that we need to figure out. And we see with Passive House, so we want to make sure that we get there. This article from the LA fires last year, so this is in the New York Times, unsafe to inhabit. You know, there's a lot of been written about this now. Yeah, exactly. I was right with you, Graham. So all the gray marks there are houses that were destroyed by fire, and the yellow dots are homes that were tested for this, and they found for toxic substances after left by the fire, and that so many homes were essentially unrecoverable, that need to be brought back down to the studs and essentially rebuilt as if they're new. So many families fighting with the insurance companies and wishing that their houses had actually burned down because they could get a claim in a much more straightforward way and move on with their lives. So I know a lot of people out there are grappling with this. I can't imagine it. I have been to Altadena and the Palisades since. It was there in the fall, and meeting with some folks. Really, really tough. But to think that you survived the fire, but you're just destroyed by the smoke is really, really disheartening. And the thing is, you know, these fires, they're bad enough when they're in the forest. When they come through a neighborhood of buildings, they're absolutely toxic. It's filled with foam, whether it's the furniture, the interior finishes, the insulation, and not just foam, but any number of things that are filled with toxins. You know, the batteries, of course, and different industrial components. So it's a completely different situation. And if we can keep that smoke out, why wouldn't we? So let's test our air tightness and let's make it really airtight. Let's go to 0.6. And the teams, the passive house teams, once they've done it a few times, they'll hit 0.3, 0.2. You don't want to bet on 0.2, but you could say 0.4. Teams could, and what happens is you have the energy model and you're optimizing with the passive house energy model. And 0.6 is the limit. That's the worst you can do. So that's in to begin with. And you've got your insulation levels and your window performance. Now you say, well, I know we can hit 0.4. And you put 0.4 in the energy model. Now all of a sudden you can start removing insulation. You can ease up on some other aspects. And the air tightness, you could hit 5 ACH, 3 ACH, or 0.6 ACH with, if you know what you're doing, with practically the same amount of effort. It's really about intention. It's about sequencing. It's about understanding how things come together. So I like to say air tightness is one of the few things in life where you can get something for free just by paying attention and really get a lot more value out of your building. You got to think about it as a system. You've got to think about it completely. This is a bubble you're building to keep all that pollution out. And we're ventilating the building to get the interior toxins out. Now, I'll make the point, I don't think I've done this yet. You can open the windows. You can use natural ventilation. Natural ventilation has been a core strategy and part of Passive House from the beginning, like we're talking about the homes in colder climates. We just can't depend on natural ventilation because if there is a wildfire over the hill or a couple states away and you're getting that smoke, you can't open the window. Or if you're by a highway or industrial area, or there's some prevailing wind that there's some odors you don't want, there's any number of reasons, allergens from the outside, you want to be able to have the choice of having the windows open or not. With Passive House, you have that choice. If you're relying just on natural ventilation, you don't. You're going to suffer poor indoor air quality when you close it up because of the weather or pollution outside. And typically that's going hand in hand with a leaky enclosure, and there's just air coming through the enclosure anyway. Yes, you can effectively close them. Yes, yes. Air barriers, all types. There's fabrics, there's sheathing, there's plastic, there's self-adhered, there's boards, interior, exterior, liquid. You just need to think it through. And there are strategies for making it more robust. What we don't want to do is rely on sacrificial layers. So traditionally, airtight drywall was kind of de rigueur in terms of high performance building. You caulk the joints and do all of that. But at the end of the day, drywall is a sacrificial layer. It's going to get beat up. It's going to crack. It's going to pull away. It's not going to have the longevity. And we need durability. Oftentimes, and they should be, they're buried in the construction. They're not, you're not able to get to them in that way, and they're protected. Service cavities is a nice way to run ventilation, to run wires with minimizing the penetrations. You can see here, if you had to have a penetration at every outlet and switch through the air barrier, you'd have a lot of holes, hundreds of holes through one of the most critical elements of the performance of the building. And if we can really limit those, hopefully to just a handful, the services and some others you can't get out of, we have a much better chance of maintaining that high quality air tightness. So we're going to do a blower door test. and another resident, and it's not the resident that this is a picture of, although it is a passive house. So while the outdoor air quality can vary significantly, indoors the quality remains very good. And this is, again, this kind of basic flexibility that's built in with the buffer of the performance. So ventilation is foundational. And for all kinds of things, this is from a school in Germany and data where natural ventilation, where it's closed up uh, and in colder time, and the CO2 numbers are going off the chart. Here's 5,000 parts per million. And then in a passive house where we have the ventilation, and we have it clearly below 1,000. There's a lot of great data out of the UK, which I need to get. Scotland has just basically mandated that passive house is going to be required for all their schools, and they have a lot of schools that are being built now to passive, and any number are being operated right now with excellent results. And in terms of durability, in terms of the quality of the environment for the students, staying awake, being more alert, in terms of the energy savings for the governments, really tremendous. We're going to have Anne Marie, a little quick plug. I was just emailing with Anne Marie Fallon, one of the drivers of this movement in Scotland. She's coming over for the conference. So if you're involved in schools in any way, you should come to the conference and hear the lowdown on how they're making it happen in Scotland. If they can do it, we can do it. The delay, this comes to the buffering, where we have these peaks and we have buildings swinging with the night and day, and a passive house is basically flattening those. I don't know what the scale is of these curves or anything, but I would not take it too literally. This is just, again, this idea of the buffering of a passive house and the flexibility that that gives. So you don't have to cool in those afternoon hours that the California regulators are really worried about. You can carry through those hottest hours of the day and cool in the off-peak hours. In the summertime, you're going to need to cool because even if it's cold, it can hold it, but you have internal heat gains, and you have the heat gains relentlessly from the outside. It's going to warm up. It's not like if you're in the winter climate and you have the internal heat gains and the solar gains are working to balance out those losses when you don't have the heating system on. So slightly different. Net zero versus simultaneity. So the idea of being able to have that modest solar array. We see the code in California moving towards that. We don't need to have massive solar arrays. Passive house allows for solar and encourages it in some ways in the certification programs, but they can be quite modest. Back to our optimization versus the tuning the curves, the production versus the demand. So this is a retrofit in Sunnyvale, California, and by Bronwyn Berry, Passive House BB. And she, it's a modest home and quite small heating loads. So these are peaks, right? It's under a half a ton for the heating, and the cooling load is under a quarter ton. So it's quite remarkably small. And part of the issue is, the manufacturers are getting better and better at sizing down the equipment. Modest solar array. Equipment for this we see here, and there's I'm not sure if this is just a utility room. I think it is, but it's this pretty sizable room where they have the heat pump hot water heater, induction cooktop. This is all pretty standard. Heat recovery ventilation, split heat pump heating and cooling with a motor that can, oh, it's in the garage. Hey, Bronwyn. Thank you. You can really talk about this next couple slides. Maybe you need to chime in. So this is great. What we have here is the analysis, and I love these. And Bronwyn and I were just talking about getting more such data, because I find this slide is one of the more powerful ones out there around our building stock and what we can see. So we have the average use of the typical home in the same zip code, energy use over the course of the year. We have the predicted energy use from the energy model, and we have the measured energy use of the actual usage. And it's nice to see that, it's okay to be operating a little bit better than you predicted. We want to be, there's a lot of these things in Passive House that makes it a little conservative. You don't want to be on the other side where, if with my house in Brooklyn, for those folks, if the 3 tons wasn't enough and they really needed 4 or 5 tons, I would have had a big problem operating under. It's great. Really smashing the usage there. And we talk about net zero. This is true net zero, right? Where or truer net zero. I don't know why is the average so low? I don't know. Maybe Bronwyn knows.
That's the actual monthly produced average. You're looking at similar in that same zip code. The blue line is not, that's like an average home in that exact same zip code.
Right. But the question was, why is this so low? But is it?
You're going to look at the yellow line. The yellow line is the measured one.
No, that's yours.
Use.
I think the question was, Karina Antonia, why is the energy use for an average home in the same zip code in California in summer so low? So the blue is the average home.
Yeah, sorry, it just struck me that
so it's July, August, summer. Yeah. It's just that's this neighborhood. It's generally Bay Area, and it's probably gets the benefit of the
It's
fog.
mild.
Yeah, the marine cooling load. So
it's not as hot.
Exactly.
Yeah.
It's Bay Area gets our fog marine layer.
Yeah.
But it's still, our actual is just effectively a flat line, like summer and winter.
No, it's so impressive. I love this slide.
But the other, this slide tells an even better story.
Yeah. So we've got the production in the yellow bars here below, and the usage, the total house usage, and then the vehicle charging thrown in above is all coming out on average slightly under what's produced. So we're getting that zero, but there's not a huge swing here, right? There's not a crazy movement one direction or another on the usage. And the solar is going to bump up a bit, right, in those sunniest months, but it's not out of whack the way we see in the conventional setup. All right. When the power went out, we could safely shelter in place until the utility got it running again. So we hear about blackouts, and it could be in a heat wave, which you have a limited amount of time. It's still days, it's not hours, to shelter in place before hopefully your utility gets things up running. But you should be safe. It should not be life-threatening. And if critically, if people can't just get out, elderly, sick, you don't have a place to go, to be able to stay in place, super important. And then in the wintertime, you can essentially shelter in place indefinitely, because the homes achieve essentially an equilibrium given some internal heat gains and the solar gains, the passive solar gains each day. It won't be terribly comfortable, probably about 55 degree in a harsh winter condition, but you can survive. And so this kind of survivability is super important. And really, if we're looking at these buildings and we're investing in them, uh, um, and they're going to be around for a long time, we see the climate, how much the climate's moved in the last 20 years, and the heat waves and the cold snaps coming. To be able to protect yourself and your family or others that you're investing in property, hugely valuable to be able to do that. All right, so Bronwyn, I'm going to let you take over here because I stole these slides from you. So this is your Pebble Beach house. Full credit, of course. Bronwyn Barry, Passive House BB. There she is. So let's talk about it for a minute. We've got 13 minutes left. Let me talk and then you fill in. Because
Oh,
I've
for
got the
it, I have no
abbreviated.
preparation, so you go ahead, Ken.
So we've got a case study of it on our website. You can check it out. Yeah, no, you can hang out. It's okay. Quick AXO here section through it, identifying some of the basic elements around the performance. I know people are interested. The roof R36, the walls are R19, the floor R32. These are moderate values. They're nothing crazy here. But it's that optimization, right, of bringing it all together. And so we see, this is a 2x6 construction, and there's no continuous insulation on the outside. It's just there's continuous insulation below the floor, and there's continuous insulation at the roof. At the wall, it's just 2x6 construction coming through. We have some insulation infill at the rim there where the joist is coming through. High performance window. I believe these are made in Kansas?
Yep.
Excellent.
We didn't need the triple pane either, but it just was how the window came, and it effectively cost the same as it might have been slightly cheaper for the double, but not exceptionally. And it's on a busy street, so the clients love the acoustic separation that the windows really give them.
Fantastic. Yeah, the acoustics. There's another thing clients love in cities or in any noisy, prone to some noise, how quiet and peaceful it is. Let's see here. Took the set. Nothing fancy here about the window install, except it being well thought out and calculated. And so we have thermal bridge calculations to make sure that we're minimizing that. And so at all of these junctures, we're taking a look at it where the frame is meeting the wall, where the wall is meeting the roof, where the floor is meeting structure and the wall. Any thoughts on this?
Yeah, the one thermal bridge that made this all really eye-opening was the wall, the rim joist at the second floor to the exterior wall. Yep.
Yes.
If I hadn't had that thermally calculated, we would have had a condensation cold spot there. Inside the floor where you wouldn't have seen it until it's too late. So it was really eye-opening to get the analysis done, or as you mentioned, all the other junctions pretty minimal, but that was the one that really, super grateful to do certification, because otherwise I wouldn't have bought that. So you don't know until you know.
Yeah, excellent. Excellent. That's great. Smoke tight. I still call it airtight. Bronwyn calls it smoke tight. She's hammering it home. So we've got the red line. It's not a heavy red line like the other diagram, but we see the red line going around, continuous air barrier, and how this is tying in to the windows. And from, again, it's the junctures that make or break the building performance. And these junctures are where Passive House really makes us focus. And once you've figured out the detail and working with the contractor, they'll help you make a better detail and more cost effective and deliver the performance. So there's an aspect of team building there as well. And the PHPP. So here's the verification page and the energy model with shockingly low numbers. So the 4.75 is the heating demand number. We're at 1.12. This is Pebble Beach again. And the cooling is at 2.39. So really nice. And that is the end of our presentation. There are some resources here. We'll share PDF and with everybody. And yeah, I hope you enjoyed this. If there are any questions, please feel free to open up your mic. Great to have some cameos here. There are some great Passive House people in the room. Really glad to have your input.
I've got a question, Ken, and to all the other perhaps more experienced professionals in the room. I'm building a house that we're going to do an exterior insulation package on, and there are several mid-story roofs, so little overhangs that are halfway up the building that project out roughly 2 feet. And so that's been a crux point for how we're going to minimize the thermal bridging there. And I was wondering if anyone in the group has any recommendations for how to do that. We're in climate zone 6, so it does get very cold up here in Tahoe.
Yeah. So the one thing, I don't know if this detail is actually like that or not, but we could use it as an experiment. Maybe I should be able to draw on this. I don't know. But if you imagine this wall keep going up, and this is one of those mid roofs.
Yeah,
I mean,
exactly.
you want to, I don't know in terms of the loading, what kind of loading do you have on the roofs? Is it just the snow load?
Snow load, yeah.
Yeah. So essentially you don't want it, you want to be able to fasten that back in and have the structure go up through. And so your insulation is continuing up, your air barrier is continuing up. And there are ways to detail that, whether, at a midpoint or not, but this is strapped on like you would hang a piece of millwork, a kitchen cabinet. You
Yeah.
hang the roof eave.
So it's ledgered on there, and then you're relying on the interior insulation for your thermal break versus the exterior there.
So
okay.
as long as that parka stays continuous, right? And essentially you're hanging something off the refrigerator, as long as the refrigerator stays intact.
Okay, that makes sense. Thank you.
Yep. Is it iframe? iframe?
Yeah. I used to work up in Tahoe, and you'd often see a double roof type assembly. So you may have your roof insulation installed in a bay below, and then you may have a roof built up on top of that. And in your case, trying to achieve a passive house assembly, you may have a beefier top roof layer that you would hang your rafters off of from below. And that way you could pick up that extreme snow load, because if you have deep overhangs like you usually want to have up in Truckee or around that area, the load at the outside edge especially when you get like ice dams and things causing buildup. The load at that outside edge is pretty extreme. So you may have to have a beefier engineered solution than just the insulation solution. So if you have the opportunity to talk to your architect or your engineer, um, you may work hand in hand with them to get rid of your thermal bridge, but you may pay more money for some more structure to allow you to do that. It depends on what your goals are. There'll be trade-offs either way.
Yeah, our primary goal is to move the condensing surface to the interior, so we're not getting condensation on the backside of, or sorry, to the exterior, so we're not getting condensation on the sheathing. And so we've explored a couple options. One of them is monopoly framing and basically zip sheathing all the way around with no rafter tails, and then monopoly framing over top of that structure with LVLs that project out to create our overhangs, and then putting foam on that. So we're exploring that, or framing over an entire second roof on top of the structural roof. So it sounds like similar to what you're talking about.
Yeah, the snow loads are so big, depending on where you are, that you need an actual roof structure at the eave. It
Got
can't
it.
just get tacked on.
Got it.
Yeah,
Got
the
it.
engineer's working on that.
Odd.
Hopefully they'll come up with something where we can meet the snow load calcs and also get our continuous exterior insulation on the roof.
Yeah, you could also think
Yeah.
about it too as if you can't get it on the exterior the way that you want it, you may be able to pull some space inboard and get more insulation towards the interior of the building and achieve the same goal that way.
Yeah, there are a lot of detailed ways to approach these things.
Yeah,
Thanks.
good luck, man.
Appreciate it.
Yeah, great. Excellent. A lot of moving parts in those situations. Any other questions, thoughts? Oh, I didn't go. Sorry, should we finish the slides? We're at time.
Almost. Yeah, I can try to go through the closing slides really quick, and then if there are more questions at the end, we can do
Sure.
those. So, if I know there were a lot of energy code questions on the chat initially, so if you are curious and have more questions, we have a free code coach service, and that you can either call or reach out online through our web form. And that's Title 24, Part 6, which is energy code, and Part 11, CalGreen code as well. Next slide, please. And if you have any questions on CEUs, and those should be distributed automatically, but if you encounter any issues, my email is on the slide right there. And as a reminder, that slide deck and recording will reach your inbox in the next couple of days once we have that processed. And we do have upcoming courses. We have Builders Perspective on heat pump water heaters, and that's with Jennifer Rennick and Karen Collaborative, who is with no, My Corgan, which is from Current Collaborative. And since there were a lot of energy code questions, we do have a series of energy code in practice, single family additions and alterations. And then the next few ones will be on ADUs, multifamily, and non-residential. And we also have an office hours style webinar focusing on load calculations. And additionally, not on the slides, but 3C Run offers scholarships for the Certified Passive House Designer training offered by Passive House Network. So for those of you who are within the 3C Run region, if you'd like to learn more about that, I will share that link in the chat for more info.
And I'll give a plug if you're outside of it, but happen to fall in PG&E's territory. They also have incentives for CPHD training.
There we go. So lots of resources. And if there are any more questions, feel free to put them in the chat for Kent to answer. Or if there are any 3C Run questions, I'm happy to answer those as well. All right. I don't see any movement in the chat, so that might be it. And we are at time. Thank you so much, everyone, for being here. And thank you as well, Ken, for leading this great training.
Thank you. Thank you, everybody. Feel
All
free to
right.
be in touch.
Thank you.